Hello, welcome to Math 1100 revision. Today, we're going to look at the 2nd of November 2022 mathematics paper, test 1. To have this underway, let us look at the first question, which says, let C and D be any two sets. Simplify, open brackets C union D, close brackets, intersection, open brackets C union D, complement, close brackets. Now, when we are dealing with such a question, first things first, you need to check out which one is common. So the common value there, or the common set rather, is the C, which we're going to put outside here. And then the second value which is common is the union part. So we're going to say union there. And then in the brackets, we're going to have D as well as D complement, of course, with the intersection symbol there. At this point, D intersection D complement will give us an empty set, because the complement of a set itself is an empty set. So when we have C union of an empty set, the value is simply the set itself. So our value simplified is simply C. We'll move on to question number 2, which says express 0.833 bar in the form A over B, where A and B are integers and B is not equal to 0. Well, in this case, all we are dealing with is we're trying to express that value in a rational manner. Now, all we have to do is to say, let x be equal to the same value that we are given. Now, the most important thing that you need to consider is the repeating value, which is 33. Now, in this case, there's only one dp that is holding a number that is not repeating. So we need to multiply by a 10 on both ends. So 0.833 multiplied by 10 is going to give us 8.33. Then at this point, the repeating value is 33. So we need to make sure that we put a point behind the repeating value. So how do we do that? We multiply by a number that has 2 zeros. So we multiply both sides. Where there's 10, we multiply by 100. And then also at the end here, we multiply by 100. So 10 times 100 will give us 1000x. And then 8.33 times 100 is going to give us 833.33. Remember to say the 33 is repeating. Now, at this point, we know to say, we can simply say, therefore, 1000x minus 10x is going to give us 833.33 bar minus 8.33 bar. The idea is to get rid of the bars here, the repeating value here. Now, at this point, we can move on to say 1000 minus 10 is going to give us 990x, which is also going to be equal to 833.33 minus 8.33 is going to give us 825. So we're going to divide both sides by 990. And then when we cancel there, we only need to reduce the number or to express it into its simplest form. So we know to say 3 can go here, and there we're going to get 275 and then 333. Also, we know 5 can enter there and there. So 5 into 275 is going to give us 55. And 5 into 330 is going to give us 66. At this point, we can simplify it further by saying 11 can go into 55 5 times and 11 into 66 6 times. At this point, we cannot express it any simpler way. So at this point, we know to say our value is going to be 5 out of 6 as expressed in a rational form. So you need to get your calculator and then punch in 5 divided by 6. It has to give you the original value, which is 0.833 bar. Well, we move on to the next question, which is question number C. Question number C reads, solve the equation, the root of 10 minus x minus 2 is equal to x. So when you are dealing with radicals, these are very simple things, because you need to make sure that one radical is on one end and the other values are on the other end. So at this point, this 2 is supposed to move to the right hand side there. So we're going to have x plus 2 because it was a negative 2 here. Now, how do we get rid of the radical? We multiply both sides by the power of 2. So we're going to have power 2 there and power 2 there. So the radical is going to cancel out, and then we're going to have 10 minus x. And then we have x plus 2 raised to power 2. It means the value is repeating. Now, at this point, we expand. We're going to say the very x here is going to multiply everything that is on the other bracket, and the 2 there, everything that is in the bracket. Now, at this point, we continue with our calculations. It's x times x will give us x squared. X times 2 is going to give us 2x. X times 2 is going to give us 2x as well. And then 2 times 2 is going to give us 4. The like terms are already together, so we have our 4x there. At this point, we continue. We have our 10 minus x here. We get our like terms. Of course, we have our x squared here, and then we have our 4x. The x is going to move there. We'll have our positive x, and then this is our 4, and then we have our negative 10 there. So we have our x squared plus 4x plus x, we got 5x, and then 4x minus 10, we got negative 6. At this point, we know to say here we're trying to look for the product and sum. The product is our 6 here, and the sum is our 5 there. So the two values such that when we multiply them, we're going to get negative 6. When we add them, we're going to get 5, negative 1, and positive 6. So we just use the shortcut way. We know to say when we try to factor out this, we're going to have x minus 1 and then x plus 6 there. So we will say therefore x minus 1 is equal to 0 and x plus 6 is equal to 0. At this point, our x is 1 and our x can also be negative 6. Now, you don't need to end there. You need to check which value is correct there by replacing where there's x. Of course, when we use the first value, which is x is equal to 1, where there's 1, when we put where there's x rather, when we put 1, we're going to have 9 in the root, and then we have our 2. Of course, the answer is supposed to give us 1. So we have our 3 there. The root of 9 is 3, and then we have minus 2 there. When we subtract, we're going to get 1 is equal to 1. So meaning this value is correct. Now, let's check up with the other value. Where there's x, we're going to replace with negative 6. And then when we have negative, it's going to give us positive. And then we have 16. 16, it's 4. 4, we remove 2, we'll get 2. So the 2 is not equal to the 6 that we have, meaning this value is a wrong value. So we cannot use that value. So the only way you can conclude is to say, therefore, the correct value of x is 1. So that's all about question number 1. Let's quickly move on to question number 2, which reads, let f of x be equal to x power 2 minus 2x minus 1. Now, when we are given such a function, and then we're asked to say, we need to determine the nature of the roots of f of x. Now, first things first, you need to find out or to list down the data of this expression that we're given. So the value of a is 2, and the value of b is negative 2, and the value of c is negative 1. Now, we use the formula for finding the discriminant of a value. So the discriminant is denoted by the symbol d. So discriminant d is equal to b squared minus 4ac. So we just replace with the values that we have, or the data that we have. Where there's b, we'll put negative 2. And then where there's a, we'll put 2. Where there's c, we're going to put negative 1. When we calculate, we're going to have 4 there. We multiply everything, we're going to get positive 8. When we add, we're going to get 12. Now, how do you conclude? Now, you conclude in such a way that since d is greater than 0, then the nature of the roots of f of x are two distinct real roots. It means you've concluded there are two distinct real roots. Now, we move on to the next part of the question, which says solve f of x equals to 0 by completing the square. So if f of x is equal to 0, how do we solve it? By using the completing of the square method. Now, we know to say, we've been taught to say, where there's f of x, we can replace with 0. So first things first, we move the constant value the other side. So this is our 1 here. And then we check, is our a value, the coefficients of our a value, if it is not equal to 1, then we need to divide across. So we're going to divide across by 2, 2, 2, 2 everywhere. So our 2 is going to move, and then we're going to have our x squared. 2 into 2 it's 1, so we're going to just to say x, and then 1 over 2 is simply a half. Now at this point we know to say we need to find half of the b value. So half of negative 1, it's going to give us negative 1 over 2. Then we square it and then add it to both sides as required by the method. Now, so we have our negative half squared and half squared here on both sides added. So remember to say we can factor out by saying we get our x here, and then we get our negative 1 over 2, close our brackets, and then we raise it to power 2 there. On the other side, negative 1 over 2 squared is simply going to give us 1 over 4 positive. So we continue. We are going to give the roots on both sides so that you can get rid of the power. So we're going to have x minus 1 over 2 is equal to, when we add half plus 1/4, it's going to give us 3/4. So when we find the roots of these, it's going to give us plus or minus 0.8660 using a calculator. So now at this point, we're just going to move our like terms together. So we're going to move our half on the other side. So when you punch in that value in a calculator, the first one is negative 0.8660 plus 1 over 2. The answer is negative 0.366, or positive 0.8660. The answer is going to be 1.366. At this point, it means you are done. Now, let us move on to the next part of the question, which says sketch the graph of f of x. Now, how do you sketch a graph? So basically, you already know one thing. You found the values of x when y is equal to 0. So those are the two values. Now, you need to find the turning point of your graph. Where was your graph turning? So the turning point is calculated by the formula x1 plus x2 divided by 2. So the two values, you add them and then you divide by 2. When we add the two values, we get our 1, and then we divide by 2, which is going to give us 0.5 for the values of x, where the graph was turning. But if in the x coordinate we had 0.5, how about in the y coordinate? Where was it turning? So you need to replace the 0.5 in our original equation. So this is what we're going to do. When we replace 0.5 everywhere in the original equation, so it will be 0.5 squared, and then 0.5 there, then you do your calculations. So 0.5 squared, you punch in on a calculator, multiplied by 2, it's going to give us 0.5. And then 2 times 0.5, it's going to give us negative 1, and then you have a negative 1 there. Punching this in the calculator, you're going to find that you get negative 1.5. So that is where the turning point is in the y-axis. So the values that we have negative 0.37 to 2 decimal places when y is equal to 0, or positive 1.37 when y is equal to 0, as we got the values from here. And then when x is 0.5, our y is negative 0.5. Now, we can use this coordinate box to plot our graph. So our graph is going to look like this, because they'll meet here. The other points will meet there. Where is it going to turn? Like we saw, it's going to turn at this point, where y is equal to negative 1.5. So at this point, this is how our graph is going to look like. It's going to look like a smiley face. And then remember to write the original name of the graph that you've shown. Very important here. So it means we're done and dusted. Now, we look at the B part. The B part needs us to resolve that equation into a partial fraction. Now, how do we resolve that into a partial fraction? Now, you first need to break it down. At the bottom there, the denominator is supposed to be broken down. So when you observe that one, you will see that that value that is down there is a completing of a square. So the completing of that square, when you deal with it, it's going to give you something like that, because that's a difference of 2 square rather, not completing of a square, my bad. Now, at this point, you look at the degree of the x values. So the degree of the x value here, it's power 2, but the degree of the numerator, it's power 3. So at this point, you need to divide, because the denominator, this is an improper fraction. So you need to express it as a mixed fraction where you have a whole number and the numerator and the denominator at the bottom. Now, how do we do that one? We need to use long division. Of course, we're going to say x into 3x. It's going to give us 3x there. When we multiply, we're going to get 3x power 3. And then 3x times negative 4, it's going to give us negative 12x. So the like term is that one. So you need to press it there, not here, because here we have a square part. Now, at this point, we continue with our calculation. So here we subtract. When we subtract these, we're going to get a 0. This, we just bring it down because there's a 0 here. There's nothing there. So we just bring it down the same way it is. Then negative 16x minus negative 12x, it's going to give us negative 4x. Then we bring down the 20 at the end. We continue. X power 2 into this, negative x power 2 there, it's going to give us negative 2. So when we multiply, we're going to get that one. Then we continue to negative 2 times negative 4, it's going to give us positive 8. At this point, these are going to cancel out, and then we have our value of negative 4x, and then when we subtract 20 minus 8, it's going to give us 12. So at this point, we cannot simplify it any further. So it means the values that we're going to have when we divide this into that one, it's going to be 3x minus 2 plus the remainder, which is on top there, and the same denominator there as in the original equation. Now, at this point, we can now go ahead and resolve the right part of our statement into a partial fraction. So by saying a over the first denominator and then b over the next denominator. So at this point, we are going to get the left-hand side, which is what we have here. And then for the right-hand side, we know to say the two denominators are these. And then we say this into that one. It's only going to cancel out this. And then we have our a multiplied by this part. This is what we've written here. The same thing we're going to do on the other side. The x plus 2, when it enters here, it's going to cancel out this part. And then we're going to have b multiplied by x minus 2. Now, at this point, work has become way too easy. Now, we go ahead by saying, because these denominators are the same, we cannot do anything but say even the numerators are the same. So we have our negative 4x plus 12 is equal to a, open bracket x plus 2, close the brackets, plus b, open brackets x minus 2, close the brackets. Now, how do we go ahead at this point? We're going to use the decomposition method. We get rid of one value. So when we let x be equal to negative 2, when we put it there, it means we're going to have a 0 here. It means we've decomposed. So where there's x, we're going to put our negative 2 across, even here negative 2 as well as there. So we're going to have a negative 4 multiplied by negative 2 to get negative 8 plus 12. And then these will go. We have negative and negative will get negative 4, which we have there. Now we continue. We're going to have to divide after adding 8 plus 20 there. So let's bring it this side here. So we have our 20 over 4, both sides, so that we can get rid of these. And then we have our b part as negative 5. At this point, we continue. We need to find the value of a. Now, how do we find the value of a? We get the original equation, which is negative 4x plus 12 equals a, open and close x plus 2, plus b, open and close x minus 2. When we put 2 here, it means we can get rid of the b part. So we're going to say let x be equal to 2. So where there's x everywhere, we're going to replace with 2 across. So negative 4 times 2, it's going to give us negative 8 plus 12. And then we have our 4 here, 4a, and then these will go. So when we add negative 8 plus 12, it's going to give us 4 positive. Divide both sides by positive 4, positive 4. So these will go. And then there into that one, it's going to give us 1. So these are the two values. We have a negative 5 and positive 1. So you just copy the original equation, which is here, and say, okay, fine. Where there's a, we're going to put 1. Where there's b, we're going to put 5, negative. So that's where this minus is coming from. Remember to say this was the first value, the whole number. So you indicate it there, then you say plus what you have here as a partial fraction. It means you have decomposed the fraction. So watch out for the next part of the video. Enjoy.